So, like, what is classification versus detection? Like, if you have a if you have in a picture, you have a breeze, you have a dog. Classification means you are just processing the image and finding what all objects are present inside the image. Like, you are just telling like it's there's a dog in the image or there's a breach in the image. Detection means properly telling and like where the dog or the breach exists in the image, so which is very hard to find. So for our application we have a two mode, like a object mode and a scene mode, where we'll find out the object where the objects are placed, and we will also in the scene mode we'll find out what is there in the scene, like it's a forest or it's a tree and those stuff. What is fast RCNN? It's a region-based convolutional network, a fast object detector implemented with Caffe, and which is available on GitHub. Basically, it has two layers: a region of interest pooling layer and a smooth L1 loss layer, and it's much faster than the traditional conventional regional conventional network. Like how the fast RCN works, like basically, like for this picture we have a man riding a fish bike, so we have to detect a man, fish, bike, and localize in this image. So in this network, it has a traditional conventional network which detect the object in the scene, and simultaneously there is a method detect object of region, so which will get the region where the object is present. And both this layer goes into a new layer, region of interest pooling layer, which will find the candidate location, which predict where these objects are present in the scene. Basically in the end we have a software classifier uh, layer which gives the probability of presence of different object in the image, and there's also a regressor which will tell like size of the box where the object are in the image. This fast ASEAN is available on GitHub, and there's a it's supported by MIT, and present under MIT license, and which can easily forked and used. uh, so basically it has a two ROI pooling layer. The code for the pooling layer can be found in this file, and this will basically find the where the objects are present basically in the image. And there's a smooth L1 loss layer which is described in this file, L1 loss layer.cu, and it gives the index of where the um, size of the object where it is present. So basically faster, this RCNN is very fast, and it's give like the runtime is 200 millisecond, and the marginal cost of the proposal is 10 milliseconds. So basically our purpose of using this fast association as the we need a real-time object recognition for the application, and the mobile application has less CPU power, so we'll go with fast RCNN. So uh, why we are developing an app on Android. So basically Android is the shares the higher percentage of market share for OS in the world. So as per the current quarter 2 2016 result, like 87.6% of the phones in the world are Android enabled, so we'll go with Android phone. uh, so basically for when we want to integrate the Caffe with the Android application, there is a Caffe library which is available for free, and it's a open source, so it can be easily integrated with the Android application. So basically our Android application has three uh, core implementation. So there's a core logic activities, which will like where the core logic of our application is implemented, and there is a UX UI design layer where like basically in Android is implemented in XML file, and there's a Caffe engine library which can be used for processing the image. So the UI of the our application has four files, which is activity camera.xml, where the camera landing page is defined, where we can take the picture of any object, which has two buttons. And then when the image is clicked on with either object mode or a scene mode, this two other files are described for scene mode and for the object mode. uh, the core activities, we have camera activities, camera detect activities. In camera activity, we will initialize our camera for the application, and we can click the picture in this activity. Once the picture is clicked either on the scene mode or the object mode, in the object mode the object detect activity will be called, and for the scene mode, scene recognition activity called. We have a fragment which is utilized by the camera activity for actually making the application for both landscape and a portrait uh, implementation. We have defined both the logic in a fragment. The third part is our Caffe engine, which is a Tezutelin library. It has four files like Caffe classifier, object detector, scene classifier, vision classifier. The object classifier basically uh, gives the creator object for the object mode, and scene classifier initialize the parameters for the Caffe in the scene mode. Caffe classifier is basically the loading of Caffe library into the Android OS, and vision classifier is basically defining our Caffe pretend model, so that while processing the image we can utilize the pretend model from the SD card. So here is a working principle, like when once you click a picture from the camera preview mode, you have to click a button either on the object mode or in the scene mode. When the photo is clicked on object mode, the object activity is triggered, and it will send the picture for processing the Caffe core library with the defined object mode utility. And otherwise, if it's clicked on the scene mode, the object this clicked picture will go for processing in the Caffe library in the scene mode configuration, and the result is display in the last form, where it will give the probability of the object and the like where the object exists in the image. So this is the UI looks like for the front page. It has a two button like scene mode and object mode. If you want to do a operation for scene mode, you can click the scene button. Otherwise, you can use the object button for detecting the object. So this fast RCN for Android devices, which we can utilize for developing object recognition application. The object detection works for an image it takes 30 to 35 seconds, and for scene recognition mode it takes 20 to 25 seconds for an image to recognize the scene. It's very portable Caffe library, which can be used, and for the future use we can utilize this application like a client server architecture, where we can click new images from the application and which can be sent to the server for fine tuning the new images with the pre-trained model, so that our data set will be created for the new click pictures, and which can contribute to the new data set to the deep learning community. Thank you.